for tuning in. This is Alex Langer of Schmiede One. We are the innovation lab of Grimme Group. Grimme has been established in the 1860s and their focus is to manufacture and sell root crop farming equipment. They are most prominently known for their potato harvesters. There's around 3,000 people in the group generating 5 to 600 million euros revenue, and our focus is to augment the Grimme experience with digital tools and services. So most prominently in the past we've been creating customer self-service portals, a marketplace and a product configurator. And the second field of our work is the domain of robotics. We've been involved in building a potato harvesting robot since 2018, and the machine we've created has been dubbed Harvey One. It's in the second generation, and the focus for this season is to bring it to full autonomy with no more human labor involved. That particularly being of interest because it's a harvesting machine for sensitive crops which are subject to sorting and handling, and we'll look into that more now.
What does the future of farming look like? We don't quite know, but the premise thus far has always been to keep pushing economies of scale by creating ever bigger machinery, controlling your fleets through intelligent software and planning remotely, and then keep analyzing to crank out the last bits of improvement. This might only be viable for large-scale farming, but for niches, this is not going to be the future that we see. And therefore, we started creating Harvey One, where the use case is not large-scale farming, but labor-intensive root crops. Now, if you see fields for sweet potatoes, they're cultivated on rows, and there might be weeding work that could be done automatically. You might think of planting to be a task to automate, but the money really sits where you deploy human labor for harvesting, since you have to pick the crops manually, otherwise the skin gets bruised and they're not marketable. What you'll see here is our first generation machine, consisting of market-proven components that we took from the Grimme engineering catalog and reassembled, putting them on a undercarriage with rubber tracks to really reduce soil compression and have a machine that could be operated by the same person that also does the picking. And in this case, sweet potatoes, as you see them, might sell for 5 to 6 euros per kilogram, over 40 cents per kilogram for regular potatoes. So there is a clear benefit of deploying labor that packs everything off gently. Now, while creating a fully autonomous harvesting robot is the ultimate goal of the project, this wasn't desirable for the first year of the project, since we wanted to gain experience with the process of harvesting, expose the machine to farmers, and many things could be simulated. Also, the second and maybe most relevant aspect for us was to create a product that could be mass-produced at lower costs than we could achieve for our prototype, but for that we already had to consider certain aspects. Therefore, all the production processes that have been applied here for this robot, they are scalable and they are proven. Now, looking forward, we gradually want to increase the degrees of autonomy the machine has, and the first version has been decommissioned, the second one has been produced in a small batch. We are exposing it to the market gradually, and we'll make it upgradable in a way that automated picking, for instance, will also be a feature that farmers might opt out of because of price reasons or the way they operate. Now, what does the software of the machine look like? What you'll see here is a stereo camera attached to the front of the harvester, monitoring the profile of the rows so that we can derive the steering signal based from statistical data that we gather. Likewise, similar stereo cameras are attached to the intake of the belt, where we monitor the amount of soil to have good product quality arriving on the belt, but not overburdening the machine. Because ultimately, every extra kilogram of soil that you have to dig up and work your way through will have an impact on the fuel efficiency. Now, here it's probably also worthwhile to mention that while the machine has a 42 horsepower diesel engine, it is running on processed vegetable oil, so the environmental impact, CO2 burden, is very low. Lastly, our technical stack beyond the stereo cameras we've seen is comprised of ROS, and mostly everything is written in Python. Now, we don't quite know what the future of farming will look like, but for use cases that are outside niche applications like sweet potato farming, will be in need of much more harvesting capacity because there's only a certain time window where you might be able to harvest in regions of the world. Therefore, we are also part of a research consortium that is investigating how to deploy our machine in a swarm setting, and for that, this year we'll also have a few more fellow robots joining Harvey 1. Just like that being said, we're also very eager to have other colleagues joining, so if you're curious about us and our work, please reach out. Thanks a lot for listening.